Hey guys, welcome to the next video in the stereochemistry set. This is going to be determining R and S configurations, okay? So these are important. You're going to see this a bunch of times in your exams. And it can be useful when asked on a test. Sometimes what they'll do is they'll give you two molecules with slightly different configurations, all right? And they'll ask you to determine the relationship. Like, are they diastereomers? Are they enantiomers? Are they even the same compound? And using RNS is an easy way to figure this stuff out without playing around with a model kit or trying to start rotating bonds all over the place. Okay? And so let's get started with this example. So actually there are three cases of how to determine RNS configuration. Easiest, medium, and hardest in terms of the difficulty level. All right, and I'll explain those three cases right after we do one step. All right, just so that you guys know, because I want to say some stuff that you won't know unless you do one step first. So the first step after when you're trying to determine RNS is determine if something is chiral or the carbon in question is chiral. Okay, so this our carbon here have four unique substituents. It has a bromine, an iodine, a methyl carbon, right, and a hydrogen. Right? So that's all four unique substituents. Is it tetrahedral? Yeah. And is it sp3 hybridized? Also, yeah. So we know it's chiral, so we can rank it RNS. Remember, you can't rank RNS on something that isn't chiral. Or not rank, just assign it. So the first step when trying to determine RNS, after you determine if something is chiral, is to determine the priority of your substituents. All right, and so what do I mean by priority? We assign the higher priority to something that has the higher atomic mass. Sorry, not atomic mass, atomic number, right, which is just proton count. And if you're in a situation where you have an isotope, so hydrogen and deuterium have the same atomic number, but they have a different atomic mass, you use the one with the higher mass. That one gets the higher priority. So if you had a hydrogen and a deuterium, you on the same carbon, the deuterium would be higher priority. Okay? And so, yeah, just because deuterium has more mass. Right? And so, let's do that first. So, what has the higher atomic number here? That's iodine out of all the four substituents. All right, let's change that color actually. 1. The Br is number 2. The carbon is number 3. Remember, our substituents included a methyl, but when we're assigning the priority, you have to look at the actual atom we're talking about. So the carbon of the methyl, all right? And so our last priority group is a hydrogen, so number 4. All right, and so this is what I was talking about in terms of ranking priority. And now I can introduce the three different cases I was talking about, all right? The easiest case of determining RNS is when your lowest priority group, whatever one you assign number 4, it does not always have to be hydrogen. You can have other substituents, okay? And so it's easiest when your lowest priority group is dashed. The medium case is when it's wedged, and the hardest case is when it's a planar one, or like the solid line, the solid bond. So this is the easiest case. All right, so I'm going to write number 4 dashed. All right. So once you have your numbers, what I want you to do, cross out the one you labeled 4 and do not look at it again. And now you're going to draw a circle, starting from 1 all the way to 3. So we're going to go here, 1, 2, and 3. Okay? If your circle is going to be clockwise, you are in R configuration. Okay, that's R. If you did counterclockwise, S configuration. Okay? And remember, what I just said about clockwise is R, counterclockwise is S. This is applying to the number when you have your lowest priority group as dashed. Okay? And so let's look at what S would look like. We have this carbon here. Let's put an iodine there. Hydrogen in the methyl. So all I did is kind of just swapped one group. So now, again, assign our priorities. Iodine is number 1. You're number 2. The carbon would have been 3. And the hydrogen is 4. So I still kept the lowest priority group dashed. This is the easiest scenario. Cross out the 4 and make your arc. 1, 2, 3. And you can actually even just bring it all the way back here. So like 1, 2, 3. Okay. So our circle now is counterclockwise. And so this is now the S configuration. Okay. So it's S. That's the easiest scenario you could have had. The number 4 lowest priority group is in the back, right? And now I actually want to just show you guys one thing. So I'm going to draw this molecule here. And I want to determine if it's R or S, or even if it's chiral. So if you want to pause this video and try this now, please feel free to do so. All right? And so why did I ask you guys this example specifically? Well, you can see that 3 of our substituents start with a carbon, okay? But they're not the same, right? This is an ethyl, methyl, and this is a carbon with an OH on it, okay? So we have and so even though the first atom off of our carbon in question, if it's in chiral or not, is not, they're all carbons, the groups themselves are different. So this is in fact chiral. Okay, this is chiral. And so how do we determine R and S? Well, again, let's look at the atomic number first. Which one has the higher atomic number? The bromine. And now, what about the others? Well, they all start with carbons. So we cannot look at the carbon because the atomic number would be exactly the same. So what you now do is you move on to the next atom. Okay? So what I'm going to do is I'm going to draw it out here. So let's see. I'm going to let's draw this carbon in purple here. All right? And so I'm going to look at all 3 groups. So over here we have a carbon, hydrogen, hydrogen, CH3. Then this one is going to be just CH3. This one is going to be CHHOH. So the first thing off of the carbon in question in purple is just another carbon, so we cannot tell. So their atomic numbers are exactly the same, so this tells us nothing. So cross that out. And then look at the next atom. In this case, it's a hydrogen. And in this case, right here, we have 2 options. A carbon or the hydrogen right there. Right? You want to go for the one with the highest atomic number, so we would look at the carbon. All right? And here we had an OH. Oxygen has a higher priority than a hydrogen or a carbon. So this one right here, the lower one, would get the second priority, number 2. So this whole group gets the second priority. All right. Now what about number 3? Between a carbon and a hydrogen right here, the carbon gets the higher priority. So this would be number 3, and this would be our number 4. So you can see in this case, our number 4, our lowest priority group, is not a hydrogen. Okay. And so just another example of why it may not always be a hydrogen. So the next step, R or S. Well, like I said, cross out the 4 and draw an arc starting from 1 to 3. 1, 2, 3. Right? This is going to go counterclockwise. So that's S. Okay? So, yeah. So that's going to be the S configuration. All right? Now, let's do one more example of this sort of scenario. Now we have a larger compound here. So what's going to be our carbon in question? Well, is this the chiral carbon? No, it has 3 hydrogens, right? Not 4 unique substituents. How about this one? It has 2 hydrogens on it, right? H, H. So again, fails the 4 unique substituents. What about the carbon here? No, it has 3 hydrogens. What about this one? Well, it has this methyl group, ethyl, an OH, and also a hydrogen, right, that we don't show here. Now, remember, if we're determining RNS, we need to have tetrahedral carbon when we're talking about chiral carbons. And so, if our 2 carbon bonds are planar, and we already have a wedged OH, that means that the hydrogen we cannot see is dashed. Okay, so now we have all 4 of our substituents. So which one is going to have the higher priority? Well, the oxygen has the higher priority because it's got the higher atomic number. So that's number 1. Number 2, is it going to be between the hydrogen, the ethyl, or this methyl? Well, remember, off of our red carbon here, a methyl would have 3 hydrogens, and the ethyl would look like this, right? So if we're looking at our carbon here in blue, determining which of those, right? Well, we already know our hydrogen is not going to be one of the higher. It's probably going to be the lowest priority because we're deciding between 2 carbon substituents, which all have a higher atomic number. So when we're now looking at those 2 carbons, they have the same atomic number, so that can't tell us anything. So cross that out and move on. So we can look at the hydrogen here, or the carbon now, and this can only be looked at for the hydrogen for the next atom, right? So between a hydrogen, and a carbon, we know the carbon is the higher atomic number, so we want to look at the carbon for the molecule on the right. And since we can only have the hydrogen here, we have to look at that. So what's the higher atomic number? Well, it would be the carbon, so this carbon right here, which means that this ethyl substituent is going to have the higher priority. And you want to put the priority on the carbon, the atom immediately attached off of our chiral carbon. So right there. I'm not putting the ranking, the number 2 right there, as in this carbon, right? You have to have it on the carbon immediately coming off. And that means that our methyl is going to be number 3, and our hydrogen number 4. Let's erase all this. And so now what we need to do is draw our arc. Okay? So we have our priority groups, cross out the one labeled 4, and you can see that our 4 is dashed, so we're still in the easiest we're still in our easiest RNS configuration. So now draw the arc from 1 to 3. Okay, we went clockwise, right? And so because we went clockwise, that carbon was the R configuration. Okay, and so let's do one example now where we have the medium scenario, and in the next video I'll cover the hardest scenario. I'll make a separate video for it. So let's say we have this carbon, OH, CH3, okay, so first thing we should do is this chiral. Yeah, it has 4 unique substituents, it's tetrahedral, and it's sp3 hybridized. Okay, and so what exactly are we going to be, how exactly do we essentially number this? right? First thing, what's the highest priority group, right? So we have a carbon for the methyl, a bromine, and an oxygen. The bromine has the higher atomic number, so I'm going to put that as number 1. The O has the second highest, so number 2. Now between the ethyl and the methyl, right, the two carbons coming off of our chiral carbon, they're the same atomic number, so we have to go on to another atom. Right, so again, I'm going to draw this thing out here so you guys can see it, because there is a systematic way of doing this. So make that in purple. We have CH, CH3, and then CH, H. All right. So we look first at the carbon immediately coming off of our chiral carbon. They are both just carbons, and so their atomic numbers are the same, so they cannot tell us anything. Once you cross out one atom, you move on to another one. Now you have a couple choices. You can move to the hydrogen, or we can move to the carbon here. In this one, we only have hydrogen, so we can only look at hydrogens. Now you want to look at the one with the higher atomic number, which is naturally going to be this carbon, between a choice between the carbon and the hydrogen. So we look at the carbon for the substituent at the top, and for the one on the bottom, we only have a hydrogen as an option, so we're comparing that. So the carbon obviously has a higher atomic number, so we put that as the higher priority group. So that's going to be number 3 at the ethyl. And the methyl gets number 4. Now remember, like I said, even though we had to eliminate like this carbon to determine where's the highest priority group, and we determined that this whole area here is going to be the 3rd priority, I am not assigning this number 3 to that, all right? Some molecules can get, when they show you them in chain form, when they show them in chain form, if you assign it that way, you may get a little tripped up, all right? So you just put the number on the immediate carbon off of our chiral carbon, right? So we have our priority groups. Now what you want to do is cross out the one as number 4, right? Cross out number 4 and draw your arc from 1 all the way to 3. 1, 2, and 3. All right, so this looks counterclockwise, right? And so it looks counterclockwise, so we would write S. But when you have your lowest priority group as a wedged, when it's wedged, so our methyl was our lowest priority and it was wedged. Whatever, once you make your arc and you get your R and S configuration, you change it to the opposite one. All right. So if it looks S, it's actually R. All right. And so this is because we want to always position it so our lowest priority group is going to be dashed. And so what you could do is, if you want to take a model kit, right, build a little model and put your highest priority group, it's not highest, your lowest priority group is wedged, and then rotate it so that it ends up being dashed or going away from you, you'll see that it actually is going to look R in this compound, not S. But this is just a trick so that on paper you don't have to go through rotations or make a model kit on a test. So again, this is the second scenario. If you have a wedged lowest priority group, your number 4 wedged, do it all the same way. Draw your priorities, cross out the lowest priority one, and make your arc. Once you have your arc, whatever configuration you get, R or S, it is going to be the opposite of that. All right. And so we made it look like it was S, but it's really R. And so let's go through one example. So here, let's change things up a bit. A ring. Okay. And let's put a OH here. All right. And so how exactly do we determine this? Oh, yeah, and hold on. Let's just, that was bad. Okay. We have this compound. So where is our chiral compound? Actually, I did this for a reason. Okay, so look, where is our chiral carbon, right? Is it going to be this one here? It can't be because it has 2 hydrogens. Same for this, and same for this one. Now what about here? Well, we have 2 methyl groups coming off of it. No hydrogens, but 2 methyls, so again, it's not going to be chiral. This one has 2 hydrogens, so it's not chiral. This one has an OH group coming off of it, so it is going to be, so that's one unique substituent. Remember that if we have a dashed OH, that there's still a hydrogen there because they didn't give us another substituent, and it's going to be wedged, right? Now we have 2 more substituents left. We have this kind of right-hand side of it, and then we have this kind of left-hand side. So when you have this scenario where it's kind of like a ring, you want to see that both sides are not the same. So you can see along the little right-hand side that we have, or actually, along the right-hand side we have these 2 methyls. The one on the left doesn't, right? So yeah, so these are still considered different. Now, just want to show one thing. All right, if I erase it, I drew it kind of split in half. I probably actually shouldn't have done that. Take the entire path around this like this. You can see that if I started from that red carbon and moved counterclockwise, that we encountered this right here, the carbon with the 2 methyls, after 1, 2, 3, 4 carbons. Whereas if I went down the right pathway, so this 1, 2, it's going to be at the number 2. So these are different. All right. Even so, in rings, we can have different substituents. All right. So we established that that's our chiral carbon. Now let's assign priorities. The oxygen has the highest atomic number, so it gets number 1. This right-hand side that we looked at, as if I went clockwise, remember it has, at one point we'll have 2 methyls much sooner than if we went counterclockwise. So methyls are better than hydrogens, so we're going to put a number 2 here, which means that this would get number 3, and our hydrogen gets number 4. So we have a hydrogen, which is our lowest priority group, as wedged. So we have to, so what we need to do is cross that out. Draw your arc. 1, 2, 3. So it looks, actually hold on. So it looks, we went clockwise. So it looks like it's R, but we flipped that because our lowest priority group is wedged to get S. Okay? And so I hope this video made sense. In the next one, I'm going to go through the last situation, which is the hardest one. Still not hard, it's just a little bit more steps. And so if something in this video didn't make sense, please feel free to email me, go to the CLC and talk to the TAs. They're really good over there. And if you're on YouTube, please feel free to comment your question so that others who also have this question may see it. Okay? And so I will see you guys in the next video.